Okay, here's warm-up number 46. So first we're going to name the point of concurrency where the following line segments meet. This is a lot to remember. I've got a little mnemonic device to help remember. So if you remember the saying, all of my children are bringing in peanut butter cookies, that can help. And you notice how I kind of broke that up when I said that. All of my children are bringing in peanut butter cookies. So all of, well, altitudes, this stands for altitudes, and so it's going to be one that begins with an O, and there's only one of those in the batch, and it's the orthocenter. So the orthocenter is where the altitudes meet. Okay, all of my children is the next part. So medians, and that's going to be, the problem with the C is there's two different ones. There's the centroid and there's the circumcenter. So you still have to remember which one is which. And the medians is going to be where the centroid is. Where the medians meet, that's the centroid. Okay? All of my children are bringing in. Okay? Are bringing, that's like the AB is the angle bisectors. So I need something that begins with an I. There's only one of those. That's the in-center. And then peanut butter cookies. Peanut butter cookies. So peanut butter is for perpendicular bisectors, right? So I need something that begins with a C. I've already used centroids, so the only one left is the circumcenter. Yeah, so the one problem with that mnemonic device, you still have to remember which C is which. Which one's the centroid, which one's the circumcenter. Okay, next up, what type of a concurrency point is point P? So I'm looking at this. So I'm thinking, what meets there? I've got two different types of segments that meet there. I've got these ones where the right angles are, but then there's also these look like they're meeting there. So I have to figure out if I've got altitudes, medians, angle bisectors, or perpendicular bisectors meeting at that point. If you look at the ones that I just highlighted yellow, these kind of look like that one kind of looks like it's an angle bisector, but I don't know for sure. Those two angles aren't marked congruent. Here it doesn't look like an angle bisector. Okay, and I don't know what it attaches to on the other side because it doesn't go all the way through to the other side with the yellow lines. So the yellow lines is not going to help me. I'm looking for the pink ones actually. And the pink ones, if you look at those, they're perpendicular to the sides. They're also bisecting the sides. So this is where the perpendicular bisectors meet. So then looking up here, perpendicular bisectors, that should be the circumcenter because those pink lines are all perpendicular bisectors, so they should be meeting at the circumcenter. Okay? Then we're supposed to find PC, so PC is this piece here, okay? And the deal with this, if you look at those yellow spokes, they all appear like they look like they're about the same length. Now you don't really want to go just based on looks, but we can tell that the pink ones aren't the same length. That's really obvious, right? So you can actually use the visual clues to help you remember if you forget. But one of the properties of a circumcenter, the most important property other than what it is that it's going to be the same distance from the vertices of the angles the vertices of the triangle. So that means all three of these yellow spokes are going to be congruent. So I'm going to put 4 ticks, 2, 3, 4, 1, 2, 3, 4. All of those are congruent. Hey, this one is 6, so that means that this one is also going to be 6. So there's the length of PC then. Okay? All right, next up, I've got a centroid. So a centroid is going to be where the medians meet. Okay? So a median connects a vertex to the opposite midpoint. And same here. This then would be a midpoint, and this would be a midpoint. Okay. All right. So the property that you need to know about centroids is that each of those medians is going to be cut into a short and a long piece. So, okay, since they're talking about BL first, I'll use BL here. So if I'm looking at BL, this would be my long piece. and this is my short piece. Obviously, that's not a technical term, but you can see that this one is shorter. The shorter piece always connects to the side. The longer piece always connects to the angle, to the vertex. But you can tell just looking at it which is which. Okay, and now the deal here is the short one is going to be a third of the whole length of the median, and the long one is going to be the other 2/3. Okay, and in this case, they tell me that BL is 12, so this whole thing is 12 units. So the short piece is going to be 1/3 of that. So 1/3 of 12. That's the same as dividing by 3. So that means that this is going to be 4 units, right? And then I could just do some addition or subtraction. 4 plus something equals 12. This is going to be 8. But 8 is also 2/3 of 12, because I get 24 over 3, which is 8, right? So now I can tell those short and long pieces are 8 and 4. And that's actually what they're asking here. BP is the long piece, so this is going to be 8. And PL is the short piece, so that would be 4. And there we go. That's the end of the warm-up. See you next time.